In the last lecture, we discussed what was matter and the physical and chemicals of properties of matter and how we can observe those. This lecture, we're going to talk about how do we classify matter, how do we put it into different groupings. And one of the first ways that we classify it is based on what state it's in. So matter can be solid, liquid, or gas, and more rarely a plasma. Plasma is when you have electrons that are highly energized and are flying off of the atoms. And that really only happens in various sort of somewhat extreme cases. So we're exciting different gases. That's how we get fluorescent light, or on the sun. Okay, but we're going to take a quick look at what is the difference between matter in its solid, liquid, and gas form. So let me click on a simulation. I'm actually not going to use the one that's linked on here, but you can take a look at that one if you want in the notes. Okay. All right, so right here we see it. This is neon. Okay, really what it is doesn't matter. The temperature for now doesn't matter. But what you can notice is this is in the solid state. So if I click on solid, this is a chunk of the element neon, and we can see sort of on the elemental level, the molecular level, all these are each individual atoms of neon. Okay, so notice that as solid neon, okay, the particles in the atoms are not perfectly still. If you were to look at like a piece of solid neon, it would look like it was sitting still. But on the molecular level and on the atomic level, you have all of these little atoms sort of vibrating in their position. Okay. Now, if we heat it up a little bit and it becomes liquid, you can see now that it starts to change shape. The atoms can flow past one another. Okay, and it starts to fill the container. Then if we excite it even more and heat it up even more, you can see that again we have the gas particles, and the atoms are bouncing all over the container, and they are interacting with each other, but they are not attached to one another. Okay, so matter can be either in the solid, liquid, or gas form. Okay, and let's most likely review. Okay. All right, so compounds are a mixture of elements, okay? And elements are made up of atoms, and atoms are made up of protons, neutrons, and electrons. So I'm going to go through and kind of define what each one of those are. Okay, so a compound, like I said, is a combination of one or more elements. Okay, but they are always in fixed proportions. Okay, the only way that you can separate the parts out, separate the elements in a compound, is by undergoing a chemical reaction. You can't heat it up, you can't break it up, you can't grind it up. And the only way to separate the elements out of a compound are to undergo a chemical reaction. And a basic example of a compound is water. And everybody knows the formula, the chemical formula for water is H2O. And that's because it has, 2 hydrogens for every 1 oxygen. So it's in fixed proportions. Okay? So you can see here the water molecule, you have 2 hydrogens for every 1 oxygen. Okay, so an element is something that cannot be broken down into a simpler substance. Okay, it only contains one specific type of atom. So examples of that are like a brick of gold, okay, or a copper pot, or when we did our nitric acid penny demo, we did a penny that was pre-1982 because it was all copper atoms. Okay, or aluminum foil, okay, a sheet of aluminum. Okay, these are pure elements that are only made up of one type of atom. Okay, all of the elements that exist can be found on the periodic table. Okay, there are only a certain number. There are more being created. Again, there's some that aren't on this periodic table that you see here. There are more that are being created, in labs. But for now, pretty much we have discovered all of the stable elements that exist on the planet. Okay, and on the periodic table, we're going to learn all how the periodic table is organized, but they are given symbols and they all have specific names, and you will start to be learning those here in the next few days. Okay, so an element is made up of atoms. Okay, and all these images are sort of, the iconic image of what an atom is, and we'll learn all about the structure of an atom and how it is made up and what it's made up of. Okay, so atoms of each element have a unique structure based on the number and arrangement of their subatomic particles. Okay, the subatomic particles that make up atoms are protons, neutrons, and electrons. So what defines what an atom is, or what an element is how it behaves based on its electrons and its number of protons. And we'll get more into details of that next time. Okay? Alright, so that is the hierarchy of matter. Okay? Now, we can also create mixtures of matter. Okay? And a mixture can have a varying composition. Not like a compound that has a fixed composition, but mixtures can have varying compositions. And there's two different types. We have heterogeneous or homogeneous. Okay, and the prefixes of those words really kind of tell you what they mean. Hetero means different, homogeneous or homo means the same. So in a heterogeneous mixture, you can visually distinguish the parts. So if we look at trail mix, you can see the fruit and the the M&Ms and the nuts and whatever in that mix. Okay, so you can visually distinguish the parts. In a homogeneous mixture, you can't distinguish the parts. So in pool water, we know that in pool water there's chlorine dissolved in there, there's bacteria in there, there's dirt. I mean, there's all sorts of different things that are dissolved in pool water. But when you look at it, you can't visually distinguish each of those parts. Okay? Now we can sort of further divide homogeneous and heterogeneous mixtures. Homogeneous mixtures are called solutions, okay, and they look the same throughout. Heterogeneous mixtures can be either suspensions or colloids, and that distinction, whether you're a suspension, a colloid, or a solution, is based on the size of your particles. So I'm going to go through each one of those individually. Okay, so a solution will not separate into layers. Okay, you cannot filter out the parts. The particles are way too small that they cannot be filtered out. Okay, another thing is that you can see through a solution. Okay, light is not scattered by a solution. So if you think of the example of Kool-Aid, obviously is water with like the flavor packet and the sugar all dissolved together. Once you have dissolved all of those things in the water, you've created a solution, and you couldn't just pour that solution through a filter to get the sugar back out. And we'll talk about how you might get the sugar back out here in a minute, what you need to do to separate out the parts of a solution. Okay, a suspension. I know that's a really gross picture, but a suspension separates into layers. So if you let it sit for a while, it will eventually settle into layers. And we actually call these layers phases. Okay, and we'll talk about phases later in another reference, but right now we call phases the layers of a suspension. Okay, the particles are a little bit larger. They're large enough so that they can settle out and that we can actually filter them out. And they're typically cloudy when they're in the mixture form. So if you were to shake them up, they're cloudy and they scatter light. Okay, and then lastly, we have a colloid. A colloid is something that sort of has medium-sized particles, but it won't separate into layers. So the particles won't settle down to the bottom. Okay, and the medium-sized particles sort of stay suspended in the solution. Okay, and one of the most important specific things about identifying a colloid, like if you wanted to look at something and know, is this a colloid or a solution? Colloids scatter light. You cannot see through them. Okay, so there are two different ways in which we can separate mixtures. Okay, one is filtration. So if you have we can design filters, and it's sort of amazing how good of filters that we can design, where we can separate things out based on their particle size. So if you pass the liquid through the filter, it will trap things that are larger size particles than the holes in the filter. Okay, and remember, solutions cannot be filtered. So what do you do to separate out a solution? That method is called distillation. And distillation separates substance in a solution based on their boiling points. Okay, so if we go back to that sugar or the Kool-Aid example, if I wanted to separate out the sugar from that was dissolved in the water, I would separate them based on boiling point. So this apparatus over here is a still, and you can see I would put my Kool-Aid in here, and if I heat it up on a Bunsen burner, the water would start to boil. Sugar has a lot higher boiling point than water does. So the water would start to boil, and then as it got away from the heat, it would cool and kind of fall down into this flask here. So here I'd end up with the water, and here I'd end up with the sugar. Okay. Now, the last thing I want to kind of just throw into the end of this lecture is the law of conservation of matter. It's also known as the law of conservation of mass. And you probably heard of it stated in this way: mass can be neither created nor destroyed, it can only change forms. Okay, and that is true of chemical reactions. So when we undergo a chemical reaction, all of the things that we put into the chemical reaction, all of the mass of those things, will always equal the mass of the products, what we are making. Okay, so by undergoing a chemical reaction, we're not really destroying or creating, we're just changing the form of something. And we'll do a lab, and we will, this will come back throughout this semester as we do and perform chemical reactions.